All right, we're now moving on to the next part of this section 17b, which is day 3. And this is nothing new. We are doing completing the square. Right, so this is something that you are all able to do. We've been practicing. We've done tons of time. It was on your semester exam. So it's something that I know you can all do. There's just one slight variation to it. Right, but we have seen previously how completing the square can be used to solve quadratic equations, which do not factorize. The same process can be used to convert quadratic functions into our vertex form, and hence make them easier to graph and to find our vertex. All right, so it's the same thing that we did before. There's just one slight variation, and what this allows us to do is it allows us to take our graph in standard form, so ax squared plus bx plus c, and it allows for us to rewrite it as y is equal to x minus h squared plus k, and also with our a in front, so we can also convert this in the same form. All right, so it allows for us to rewrite it, and then allows for us to graph it easier. Let's just go ahead. There's just a couple examples. I think there's 2 of them that we're doing. So the last video was really long. This video is going to be really short. All right, so the first thing that we're going to do is this is in standard form, and we are going to rewrite this in our vertex form. All right, for right now, we're not going to do any that are dealing with the A, but that is something that we will do in the near future. This is not going to be happening on this one. But what we do is we complete the square. Now, the difference is when we're solving, we would subtract over this 1 to the other side and set it equal to the constant. Since this is a y and we subtract 1 over, it's not doing anything to it. So we do not subtract it. So what we do is we rewrite it as x squared minus 4x. And then I like to leave a little bit of a space, and we put plus 1 here. Right, now we're going to complete the square, just like we did before. We took our 4, we divided it by 2. That gives us 2. We then square it, and that gives us 4. And we add it just like we did. The difference is, since we are not moving the 1 to the other side, we used to add 4 to both sides. Now we need to do it to the exact same side. So since we are adding 4, in order for us to balance this out, if we added 4, we need to subtract 4. So whatever we are adding when we complete the square, we need to also subtract it. So this way, if we add 4 and subtract 4 to something, 4 minus 4 gives us 0. So it's changing. It's not changing. I'm sorry. It is not changing the overall value of this equation. But now, if we were to put this in parentheses, we know that this can be factored out as y is equal to, and we know that this can factor as x minus 2 squared. As we learned before, when we complete the square, we know our variable, and whatever number we get when we divide by 2 is going to be our second digit, and our sign is going to be our sign here as well. So when we complete the square, it allows us to factor this. And then 1 minus 4 gives me negative 3. So then we have minus 3 on the outside. So you see we converted it from standard form to vertex form. And now we can easily find our vertex. So our x value, since it's minus h and it doesn't change, that means our x value was positive, so it's positive 2, and it's minus 3. So our vertex is 2, negative 3. And this will allow for us to quickly and easily graph. Because if we wanted to graph this, we would just start with our vertex at 2, negative 3, and then we can go ahead and we can subtract 2, so 1 and 0, and add 2, 3 and 4, and that will give us enough points to plot our graph. All right, now there's just one more example, and this video is done. All right, same thing. We are taking this y is equal to x squared plus 2x plus 5, and we are rewriting it into our vertex form, and then we're going to state our vertex. So first, we're going to write it. Y is equal to x squared plus 2x plus 5. So when we go to complete the square, we're going to rewrite this as y is equal to x squared plus 2x. We're going to leave a space so we can complete the square, and it's plus 5. So then we will take that 2, we divide it by 2, that gives me 1. We square it, that's still 1. So we are going to add 1. And remember, since we're not moving into the other side, we need to offset it, or we need to balance it out. So we need to subtract 1. So then this is going to be y is equal to, this will then factor into x plus 1 squared, because our variable x, because this creates a perfect trinomial squared, so we can take the square root of x, the square root of 1, and then the sign in the middle is the sign that we have here. So it's x plus 1, and then it's 5 minus 1, which is then going to be plus 4. So our vertex, now the sign changed, so that meant that our h had to be less than 0, so it's negative 1. Remember, it's always opposite of the sign. And since this is plus 4, it is negative 1, 4 is our vertex. Right? That is it for this video.